So we had revised up to position of image तक हम लोगों ने कर लिया था, lateral inversion से start करना था. ठीक है. So lateral inversion in our daily life experience, while looking at a mirror, we note that a ring on the finger of our left hand appears to be in the finger of the right hand of our image, as shown in the figure 7.9. Similarly, the pocket on the left appears to be on the right in the image. So this interchange of the left and right side is called the lateral inversion. Thus, the interchange of the left and right sides in the image of an object in a plane mirror is called lateral inversion. तो ये जो लेफ्ट साइड और राइट साइड के बीच में आपस में जो इंटरचेंज होता है मिरर और उसके इमेज के बीच में, दिस प्रॉपर्टी इज नोन एज लैटरल इन्वर्जन. Okay. So now figure 7.10 shows that image formation of a letter in a plane mirror. The letter P appears in a plane mirror as opposite P. Similarly, the letter F will appear as this. Okay. Note that the lateral inversion produced by a plane mirror is similar to the inversion that occurs on a blotting paper used to dry ink while writing. तो जब आप ink से कुछ आप लिखते हो और उसको किसी पेपर पे उसका इम्प्रेशन लोगे, इनफैक्ट जेल पेन से ही डार्क करके 3-4 बार चला के जब पेपर पे इम्प्रेशन लोगे तो तुमको उसका लैटरल इन्वर्टेड इमेज दिखेगा उस जिस भी पेपर पे आपने इम्प्रेशन लिया है उस पे. फॉर एग्जाम्पल यहाँ पे जैसे ये जो लेटर P है तो ये सो दिस इज लैटरली इन्वर्टेड. ठीक है ना. The individual letter obtained on the blotting paper cannot be read directly, but it can be read by seeing its image in a plane mirror. तो जो भी लेटर का हम लोगों ने इम्प्रेशन लिया है, that cannot be read directly, but if we see the image again in a plane mirror, तो उस inverted को फिर से दोबारा है ना, दोबारा फिर से इसको इरेक्ट कर देगा वो जो प्लेन मिरर है और आप उसको रीड कर पाओगे अकॉर्डिंगली. The lateral inversion of letters such as A, H, I, M, O, T, U, V, W, X, and Y is not noticeable since their image remains unchanged because each of these letters has a symmetry about a vertical line passing through the midpoint of the letter. So if you see, ये सारे letters जो है ना vertically symmetrical है. तो अगर vertical straight line इनके midpoint से pass करेगा तो जैसा left side में आपको लेटर का इमेज है वैसा ही राइट साइड में है. तो सिमेट्रिकल है वर्टिकल लाइन के अबाउट, तो इसीलिए यहाँ पे लैटरल इन्वर्जन इज नॉट सीन, नॉट नोटिसेबल बेसिकली. Now it is because of the lateral inversion that it becomes difficult to read the text of a page from its image formed by a plane mirror, but one can easily read the text written in laterally inverted letters, so formed by seeing its image in a plane. जैसे ambulance है, ठीक है. So it is why the letters written laterally inverted like So, but one can easily read the text written in laterally inverted letters formed by seeing its image in a plane mirror. It is why the letters on the front of an ambulance are written laterally inverted, like ambulance, so that the uh, driver of the vehicle moving ahead of an ambulance reads the word laterally inverted as ambulance in his rear view mirror and gives sight to pass the ambulance first. The image formed by a spherical mirror is also laterally inverted. Now, characteristics of the image formed by a plane mirror. तो कोई भी plane mirror में जो image form होगा उनके क्या characteristics हैं? The image formed by a plane mirror has the following characteristic. First, the image is upright or erect. Second, virtual. Third, of same size as the object. And fourth, laterally inverted. The location of the image is given by the fact that image is situated at the same perpendicular distance behind the mirror as the object is in front of it. Note that if the object is shifted by a distance d towards the mirror, the image will also shift by the same distance d towards the mirror. तो जब ऑब्जेक्ट शिफ्ट करता है डी डिस्टेंस से मिरर की ओर तो इमेज भी डी डिस्टेंस टुवर्ड्स द मिरर शिफ्ट कर जाएगा. दैट इज द सेपरेशन बिटवीन द ऑब्जेक्ट एंड इमेज विल डिक्रीज बाय 2d, है ना. तो अगर डी डिस्टेंस से ऑब्जेक्ट शिफ्ट करेगा इमेज भी डी डिस्टेंस से शिफ्ट कर जाएगा टुवर्ड्स द मिरर एंड द सेपरेशन बिटवीन द ऑब्जेक्ट एंड द मिरर चेंजेस बाय 2d. Similarly, if an object moves with a speed v towards or away from a mirror, the image to him will appear to move with a speed 2v towards or away from him. Now, example, a boy standing at a distance 5 meter away from a plane mirror at A finds his image at a distance 10 meter from him at A dash. ठीक है. So, मिरर से 5 मीटर के डिस्टेंस पे है उसको अपना इमेज 5 मीटर और मिरर के पीछे दिख रहा है तो टोटल द डिस्टेंस बिटवीन द ऑब्जेक्ट एंड द इमेज इज 10 मीटर. सो इफ यू सी this distance is 5 meter from the mirror and the distance of the object is distance of the image from the object, this distance is given as 10 meter. Okay. Now if he moves to the position B by a distance 2 meter still farther away from the mirror, तो अब ये अगर 2 मीटर डिस्टेंस इधर मूव करता है फार्दर फ्रॉम द मिरर तो अब इसका जो मिरर से डिस्टेंस है 7 मीटर हो गया तो इसका जो इमेज होगा है ना इस ऑब्जेक्ट बी का वो 7 मीटर बिहाइंड द मिरर यहाँ पे बनेगा इमेज बी डैश. और अब जो ऑब्जेक्ट और इमेज के बीच का डिस्टेंस है वो कितना है 14 मीटर है. So his distance from the mirror will become 7 meter and then to him his image b dash will appear at a distance 14 meter from him as seen in the figure. ठीक है. These examples are not important. The third one is important. We will discuss that. तो ये जो एग्जाम्पल है क्वेश्चन था कि एन ऑब्जेक्ट इज एट ए डिस्टेंस 25 सेंटीमीटर इन फ्रंट ऑफ अ प्लेन मिरर. So an object is at a distance 25 centimeter in front of a plane mirror. The mirror is shifted 5 centimeter away from the object, right? So the mirror is shifted 5 centimeter away from the object. Find the new distance between the object and its image. तो 25 पे था 5 सेंटीमीटर और आगे शिफ्ट कर दिया अब 30 सेंटीमीटर पे हो गया तो इसका इमेज भी 30 पे हो गया 30 प्लस 30 टोटल जो है 60 सेंटीमीटर डिस्टेंस हो गया. पहले इनके बीच में डिस्टेंस 50 सेंटीमीटर. सो न्यू डिस्टेंस बिटवीन द ऑब्जेक्ट एंड इट्स इमेज इज इक्वल टू 30 प्लस 30 60 सेंटीमीटर. सेकेंड पार्ट कह रहा था डिस्टेंस बिटवीन द टू पोजिशंस ऑफ द इमेज. तो ये 50 यहाँ से 50 है और इसके बाद यहाँ से 60 10 सेंटीमीटर का डिस्टेंस है दोनों के बीच में. ये हम लोगों ने क्वेश्चन आंसर लिखे थे वो है. So this is the question answer which we wrote in our copy. ये मैं रहने ही देता हूँ, तुम लोग को याद करने में आसानी रहेगी. सेवेंथ वाला रेपिटेटिव था, इसको हटा देते हैं. ये सब हम लोगों ने हाथ से कर लिया था. Now images formed in a pair of mirrors. ठीक है. Now images formed in two inclined mirrors. So अगर दो mirrors आपस में inclined है तो उसमें number of images which will be formed, we are going to see that. So images formed in two inclined mirrors. For an object kept in between the two inclined plane mirrors, we get many images of the object. This is because the light rays after reflection from one mirror fall on the other mirror. In other words, the image formed by one mirror act as an object for the other mirror. This continues till no more reflection can occur in any mirror. The object and the images formed by the two inclined mirrors lie on the circumference of a circle whose center lie at the point of intersection of the two mirrors, and radius is equal to the distance of object from the point of intersection. So इसके बारे में हम लोग देखेंगे आगे जब हम लोग रे डायग्राम कर रहे हैं. The number of images formed depends on the angle theta between the two mirrors. Following two cases are possible. First is case 1. In case 1, if angle theta between the mirror is such that n is equal to, so if angle theta degree between the mirrors is such that n is equal to 360 degree by theta is odd, तो उस केस में the number of images is n, then the object is placed asymmetrically between the mirrors, and the number of images is n minus 1 when the object is placed symmetrically, that is on the bisector of the angle between the mirrors. Okay. So now example, if theta is 72 degree, 360 by 72 is 5. So images formed will be n is equal to 5 क्योंकि odd for the object placed asymmetrically between the mirrors, and the image formed will be n minus 1, that is 4, if the object is placed symmetrically on the bisector between the mirrors, because two images now overlap. Second case है, so case 2 कह रहा है if n is equal to 360 by theta is even, number of images is always n minus 1 for all positions of object in between the mirrors, whether it is whether it is symmetrically placed or asymmetrically placed. In all cases, number of images will be n minus 1, where n is equal to 360 by theta. So if the angle between two mirrors is 60 degree, n is equal to 360 by 60, that is 6. Number of images is n minus 1, which is 5. That is 5 images. That is 5 images will be formed for all positions of the object in between the mirrors. We shall now consider image formation in two special cases. First is when the two mirrors are parallel to each other. Second, when the two mirrors are perpendicular to each other. Now, images formed in a pair of mirrors placed parallel to each other. So when two mirrors are kept parallel to each other, that is theta is equal to 0 degree. Okay. Then n is equal to infinity. 360 by 0 infinite हो जाएगा. So the number of images of an object kept in between the two plane mirrors will be infinite if the mirrors are kept parallel to each other. So for two mirrors kept parallel to each other, an infinite number of images are formed for an object kept in between them. तो जैसे कि हम लोग बार्बर शॉप में जाते हैं तो जो दो वॉल्स हैं दे आर पैरेलल टू ईच अदर, तो हमें इनफाइनाइट नंबर ऑफ इमेजेस देखेंगे, एक के पीछे एक के पीछे एक, and there will be no end to it. In figure 7.18 AM and BM1, okay. So in figure 7.18 AM and BM1 are two plane mirrors placed parallel to each other. An object P is placed in between them. The image of P formed by reflection from mirror AM is I1, okay, and by reflection from mirror BM1 is I dash. The ray diagram for the formation of image I dash is not shown. Now I1 acts as a virtual object for the mirror BM1. And the image I2 is formed. Similarly, I dash acts as a virtual object. Similarly, I dash acts as a virtual object for the mirror AM and the image I double dash is formed. In this manner, many images are formed, but the brightness of the remote images keeps on decreasing because at each reflection some light is absorbed. Thus, not more than few images are seen. Figure 7.18 shows the ray diagram for the formation of one set of images only, that is I1, I2, I3, and so on. So यहाँ पे क्या होता है, एक ऑब्जेक्ट यहाँ पे है, इसका इमेज इस वाले मिरर से यहाँ I1 बनेगा और इस वाले मिरर से I डैश बनेगा, I1 I डैश बनेगा. I1 का अब इस वाले मिरर से है ना BM1 से I2 इमेज बनेगा, I2 का AM से I3 इमेज बनेगा एंड सो ऑन. और सिमिलरली ये जो ये जो इसका इमेज P का इमेज BM1 से I डैश पे बनेगा, I डैश का AM पे A डबल डैश बनेगा और A डबल डैश का BM से, ठीक है, यहाँ पे बनेगा, ठीक है ना. ठीक है, that's what is written here also. Now formation of other set of images, that is I dash, I double dash, can similarly be obtained. Okay. So all images lie on the perpendicular drawn. So all images lie on the perpendicular drawn from the base of object on the mirrors. Uses in a showroom and in a barber shop, mirrors are arranged in this manner. Note that a thick plane mirror also forms Note that a thick plane mirror also forms a multiple number of images due to multiple reflections within the glass from front surface and back reflecting surface. Now, out of these, the second image formed due to reflection from the back reflecting surface is brightest. Now, images formed by two mirrors placed perpendicular to each other. So, when two mirrors are kept perpendicular to each other, then theta is equal to 90 degrees, right? Then n is equal to 360 by theta, that is 4. So, hence, for an object placed in between the two perpendicular mirrors, the number of images formed will be n minus 1, which is equal to 3. Thus, for two mirrors kept perpendicular to each other, three images are formed for an object kept in between them. So in figure 7.19, AO and OB AO and OB are two plane mirrors kept mutually perpendicular to each other. Let P be an object placed in between the two mirrors. The image of object P formed by reflection from the mirrors OA is P1. Okay. Now the image P2 acts as virtual object for the mirror OA. So virtual object from the image of the object B formed by reflection from the mirror OB is P2 and by reflection from mirror OA is P1. Figure 7.19 shows ray diagram for the formation of image P2. Only now the image P2 act as a virtual object for the mirror OA since rays after reflection from mirror OB falls on the mirror OA. So, so now the image P2 acts as a virtual object. So आप ये देखो P का एक image बना है. So the image P of the object, so the image of object P formed by reflection from the mirror OB is P2 and by reflection from the mirror OA is P1. Figure 7.19. So figure 7.19 shows ray diagram for the formation of image P2. नाउ बाय सो हम लोग को बस ये पी जो इमेज बन रहा है ना उसी का रे डायग्राम बना के दिखाया गया है. नाउ द इमेज P2 act as a virtual object for the mirror OA since rays after reflection from the mirror OB fall on the mirror OA. Now for this the image formed by the mirror OA is P3. तो इसके लिए जो OA से जो इमेज बन रहा है दिस इज P3 यहाँ पे. इसको एक्सटेंड कर देते हैं. इसका जो इमेज है यहाँ पे मिलेगा हम लोग. ठीक है. That is the image P4 of P1 in mirror OB ठीक है. The image P4 of P1 तो ये P1 का जो इमेज है P4 और P2 का जो इमेज है P3, ये दोनों कोइंसाइड करेंगे, यही लिखा हुआ है. सो द इमेज P4 ऑफ P1 in mirror OB overlaps with the image P3 of P2 in mirror. Now, as such, three images of an object are formed. In this case, in figure 7.19, ray diagram of the formation of images P2 and P3 is shown. Similarly, we can draw the ray diagram for the formation of images P1, P2, and P4. Right? Geometrically, it can be seen that the images P1, P2, P3 and the object P all lie on a circle. ठीक है ना? तो जितने भी ये हैं P1, P2, P3, ये सारे एक सर्कल पे लाई करेंगे. और lie on a circle whose center is at O, the point of intersection of the two mirrors OA and OB, and radius is OP. Now, uses of plane mirror. The plane mirror find useful applications in our daily lives. पहला है, some of the application of the plane mirror are given below. The most common and wide use is as a looking glass. तो ये plane mirror का जो सबसे ज्यादा commonly use है वो as a wide glass है. Sorry, looking glass है. Second, in the optician's room, right? तो जनरली ऑप्टिशियंस के रूम में लगे होते हैं, जिससे कि उतने से ही डिस्टेंस में वो, मतलब जितने दूर में पेशेंट बैठा है और डॉक्टर है, उनके बीच में जितना डिस्टेंस है उतने डिस्टेंस में ही ये इतना ट्रैवल कर ले, है ना. तो उसके लिए फिर है ना, तो उतना डिस्टेंस जो है कवर कर ले लाइट, जाके मल्टीपल रिफ्लेक्शंस के बाद. तो उसके लिए ऑप्टिशियंस के रूम को बड़ा दिखाने के लिए, मतलब जिससे कि जो वो जब आई टेस्ट करते हैं, तो मायोपिक आई को जब टेस्ट करते हैं, शॉर्ट साइटेडनेस को, तो उस समय पे ये यूज करते हैं. मिरर्स लगे हुए होते हैं जिससे आपको जो है उतने रूम में ही आपको वो पर्टिकुलर 25 जो जो भी डिस्टेंस है, बेसिक डिस्टेंस, वो बेसिक डिस्टेंस तक हम कन्वर्ट कर सकें, उसको मूव करा सकें. दूसरा है इन द बार्बर शॉप. थर्ड यूज है इसका बेसिकली. Now, in the barber shop, for seeing the hairs at the back of head, here two mirrors facing each other are fixed on the opposite walls at the front and back of the viewer. तो पीछे के बाल कैसे कटे हैं ये अगर हमें चेक करना है, तो यहाँ पे हम लोग बार्बर शॉप में दो मिरर लगाते हैं, एक पीछे की तरफ, एक आगे की तरफ. पीछे वाले पार्ट का रिफ्लेक्शन जब आगे की तरफ जाता है, तो उसको फिर से रिफ्लेक्ट करा के हम लोग जो है स्टडी करते हैं. Now in the barber shop, for seeing the hairs at the back of head. Here two mirrors facing each other are fixed on the upper walls at the front and back of the viewer. In a periscope, two parallel plane mirrors, each inclined at 45 degrees with the vertical walls, are, are placed facing each other. Now, in a kaleidoscope, So in a kaleidoscope, three so in a kaleidoscope, three plane mirrors inclined each other at 60 degree are used. If small colored bangle pieces are kept between the mirrors, in a beautiful hexagonal patterns are seen on rotating the tube. The designs of patterns change. Now in solar heating device, so in solar heating devices such as solar cooker, solar water heater, etc., a plane mirror, a plane mirror is used to reflect the incident light rays from sun on the substance to be heated. तो ये हमारा हो गया सारा जो बी पार्ट ऑफ द चैप्टर है उसके नोट्स हो गए. ठीक है. बी पार्ट में थोड़ा सा ही पोर्शन है तो ज़्यादा नहीं करना है. नाउ स्फेरिकल मिरर्स इमेज फॉर्मेशन एंड देयर यूज. तो ये जो सर्कल मिरर्स स्फेरिकल मिरर्स हैं किस तरह से इसमें इमेज फॉर्म होता है और उनके क्या यूजेस हैं, वी आर गोइंग टू सी दैट. Yeah. So a spherical mirror is made by silvering a part of a hollow glass sphere. तो एक ग्लास स्फीयर का एक पार्ट अगर हम लोग रिमूव करते हैं उसको एक साइड सिल्वर कर देते हैं तो उसको स्फेरिकल मिरर कहेंगे क्योंकि ये मिरर स्फीयर का एक पार्ट है. So spherical mirror is made by silvering a part of a hollow glass sphere. Thus, a reflecting surface, which is a part of a sphere, is called spherical mirror. Now, types of spherical mirrors. So, depending on whether the inner or outer surface of a sphere is silvered, spherical mirrors are of two types. ठीक है. पहला spherical mirrors are can be either of concave, either of the form concave mirror and or of the form convex mirror. So the concave mirror and the convex mirror. So in this figure, the right part X of a hollow sphere is silvered and the coated on its outer surface, and it forms the concave mirror, while the left part Y, so left part Y of the sphere is silvered and coated on its inner surface, and it forms a convex mirror. So, pehla concave mirror is made by. Okay. So, a concave mirror is made by silvering the outer surface of the piece of a hollow sphere, such that the refraction, okay, such that the reflection takes place. एक मिनट बच्चों हैं. तो हम लोग कनकेव मिरर के बारे में बात कर रहे थे अभी. कन्वेक्स मिरर. So a convex mirror is made by silvering the inner surface of the piece of a hollow sphere such that the reflecting place from the outer or bulging surface, okay, such that the reflection takes place from the outer or bulging surface as shown in the figure. Now, brief introduction of terms. So brief introduction of terms related to spherical mirror. पहला है center of curvature. Center of curvature of a mirror. So center of curvature of a mirror is the center of a sphere of which the mirror is a part. Now in figure 7.22, it is represented by the letter C. The normal at any point of the mirror passes through the center of curvature C. In other words, a line joining any point on the surface of mirror to the center of curvature C will be normal to the surface of mirror at that point. Now, radius of curvature, the radius of a sphere of which the spherical mirror is a part is called the radius of curvature of the mirror. Thus, it is the distance of center of curvature C from any point on the surface of mirror. In figure 7.22, distance PC. So in figure 7.22, distance PC is the radius of curvature. Okay. It is represented by the letter R. तो ठीक है ना. तो P से लेके C तक का जो डिस्टेंस है, so PC is the radius of curvature. It is represented by the symbol R. Now figure 7.22, center of curvature, radius of curvature, pole, aperture and principal axis. Now basic definition of these: pole, the geometrical center of spherical surfaces. So the geometric center of the spherical surface of mirror is called the pole of mirror. Now it is the central point of the surface of the mirror. It is represented by the letter capital P as shown in the figure. Now aperture, now the plane surface area of the mirror through which the light rays enter and fall on the mirror is called its aperture. So basically size of mirror को बताता है ये aperture. तो जो surface area of mirror है through which light rays enter and fall on the mirror is called its aperture. Principal axis, it is the straight line joining the pole of mirror to its center of curvature. Okay. Now, so in figure 7.22, the line PC represents the principal axis. It can extend on either side. तो ये जो हमारा ये जो PC है, ठीक है, this represents the principal axis. ये जो diametrical line है, this represents the principal axis, which can be extended on either side. Now reflection of light ray from a spherical mirror. So from a spherical mirror, reflection of light follows the same laws of reflection as for the plane mirror. तो जैसे plane surface में angle of incidence, angle of reflection के बराबर था, वैसे ही यहाँ पे spherical mirror में भी, जैसे plane mirror में I is equal to R होता है, वैसे ही spherical mirror में भी I is equal to R होगा, है ना? और incident ray, reflected ray और normal all lie in the same plane, ये भी यहाँ पे valid है. तो spherical mirror में भी ये जो laws of reflection है, that is valid. So from a spherical mirror, reflection of light rays follows the same laws of reflection as for the plane surface. Angle of incidence I is equal to angle of reflection R, and the incident ray, reflected ray and normal lie in the same plane. Note that so in a spherical mirror, to obtain the direction of reflected ray for a given incident ray, first a normal is drawn at the point of incidence. For this, a line is drawn joining the point of incidence to the center of curvature. Then draw a line on the other side of the normal, making an angle, that is the angle of reflection, equal to the angle of incidence. This line represents the reflected ray. तो मतलब ये समझो आप इस डायग्राम में, सो यहाँ पे अगर इस रे का रिफ्लेक्टेड, ये इंसिडेंट रे का रिफ्लेक्टेड रे बनाना है, तो अगर ये इंसिडेंट रे पॉइंट ऑफ इंसिडेंस हो गया, सेंटर ऑफ कर्वेचर से पॉइंट ऑफ इंसिडेंस को ज्वाइन कर देंगे, ये नॉर्मल हो गया. ये जो एंगल है, ये एंगल ऑफ इंसिडेंस है. इसी एंगल पे एंगल ऑफ रिफ्लेक्शन बना के एक रे को पास करा देंगे, ये रिफ्लेक्टेड रे हो जाए. सेम यहाँ पे भी कन्वेक्स मिरर में भी ये अगर इंसिडेंट रे है, पॉइंट ऑफ इंसिडेंस को सेंटर ऑफ कर्वेचर से ज्वाइन करके एक्सटेंड कर दो, ये हो गया नॉर्मल. अब इससे जो एंगल बना रहा है उसी एंगल से रिफ्लेक्टेड रे बना. नाउ एग्जांपल, in figure 7.23 we are to find the direction of reflected ray for an incident ray AD on a concave mirror and convex mirror for which C is the position of center of curvature. For this, the point of incidence D is joined to the center of curvature C to get the normal DC on the mirror. At the point of incidence D, then the reflected ray DB is drawn such that angle BDC is equal to angle ADC in concave mirror and BDC dash is equal to ADC dash as in convex mirror. Okay. So we'll stop here today. यहाँ तक आप लोग रिवाइज कर लेना. है ना। और इसके आगे फिर हम लोग नेक्स्ट क्लास में करेंगे, ठीक है। तो ये जो 7A और 7B वाला जो पोर्शन है ना, इसका नोट्स में शेयर कर लूंगा तुम लोगों के साथ, जिससे तुम लोग पढ़ सको उससे, ठीक है। ठीक है बच्चों।